Hi guys. So now I'm going to start talking about surfaces of revolution. Surfaces of revolution are something like this, okay? When you see, here we're going to count this as the x-axis right here. Let me just switch over here. So this is going to be the x-axis, okay? And you can go around, okay? So how do you do that? Well, you're going to make a disk in here and another disk to the right and another disk to the right, and you can see that this cylinder here is smaller, well, it's narrower than this cylinder here, okay? The diameter of this one is a lot smaller than this one. So all you got to do is to make, you got to consider this, for example, the volume of this thing is just going to be the distance from this point, for example, to the x-axis, which is going to be the value of y for this function. All right, and so this is going to be the radius. The value of y here is going to be the radius. So pi r squared is going to be the area of this disk, and you do that summing it up all the disks. Okay, summing up all the disks in here and the big one, and you're going to get the volume. Over here, you start like with a curve right here around here. Right? You start with this curve. So this curve is actually going to be the graph. It'll be the distance from, for example, this point to the y-axis. And then this distance right here, for example, at this point right here to the y-axis, this distance is going to be the radius. So what is this distance? Well, this is x, and x equals f of y, not f of x. Okay, it's the opposite. Y equals f of x and x equals f of y. So this is going to be f of y squared, times pi. It's going to be the disk at this point. And then you get, for example, the new value right here. And then you're going to do f of pi r squared. And what's going to be r? Well, it's going to be f squared of y. So here you're going to have pi f squared of y, pi f squared of y. Down here, you're going to have the same thing, pi x squared of y, okay, f squared of y. So for you to find the volume of this whole thing, all you got to do is this, to sum up all the disks in the y direction. In here, we're doing the x direction. Over here, we're doing the y direction. So, for example, the volume of this is going to be, let's just say that this first, let me see here. You see this first curve, okay? Well, this first curve is going to be the value of x, which is x equals f of y, okay? Let me use the pen here. It's going to be x equals f of y. So what do? You make the integral pi f squared of y dy, okay, from a value of y down here, let's just say that's a, to a value of y up here, which is b. And with this, you're going to get the volume of this thing, right? Now, when it's this disk right here, then we're going to integrate, since this curve right here, this is the curve, okay, and then it goes way up there, right? Well, this curve in here is going to be revolving around the x-axis, so the disks are going to be along the x-axis. So what are we going to do here? We're going to do the integral of pi, okay, of r squared, but r is going to change. Here you have a big R, in here you have a little r, okay? So what's going to be the r squared? It's actually going to be f squared of x dx. Since pi is not going to change, we can take pi outside, okay? We can get this pi over here and erase it from here just like we did it here, okay? Take a look at this formula, take a look at this formula, they're the same. And we're going to integrate from a to b, to a value x of a, to a value a of x, to a value b of x, okay? So let's just say that a is over here, b is going to be, for example, down here. So you're going to have this big disk plus another big disk plus another one, and then the big disks are going to end, and then you have a small disk plus a small disk plus a small disk plus a small disk plus, and you keep adding all these disks. You do that with this formula. Okay, here's the same thing. If we consider this the x-axis, then there's going to be a surface of revolution, okay, by having, for example, this is going to be the distance down here, and then the distance seems to grow up a little all the way to the middle here, and then it starts going down again. Okay, it's hard to see because this is in a because this is at an angle here, three-dimensional angle. It's hard to see. This is going to be another surface of revolution, okay, around the y-axis. So here the disks are going to be horizontal, and it's going to be dy. So this is dx, this one is dy, this one is dx, this one is dy, and this one is also dy. Okay, you're going to have a curve like this for this one, and you're going to have a different curve for this one, right? Of course, this curve for this one, you're going to have a disk in here and in here and in here and in here, but you see that the disk has been erased. Okay, they use something called subtraction. This is like the piston of an engine. So they create all the disks in here, and then they come with some like a semi-dome, something like this, right? A solid in this shape, kinda. And they put it over here and they subtract it. They take the dome away, and anything that intersects with the dome goes away too. That's why you have this dent over here, okay, this curve. Well, that's about it, guys. Hold on. Let me just erase this thing. Okay. Here we have some kind of approximation of n disks. Okay. So that's what I'm saying. You're gonna get the value. You're gonna get the value of y in here. If this, let me just find the cursor. It's hard to see because the contrast is low. If this is the x-axis, okay, I'm just gonna put a big X in here. So this value here is going to be the value of y, okay? And then you do this for this disk, and then you do this for this disk, and another one for this disk, and another one for this disk, and another one. Now you have 1, 2, 3, 4, 5, 6 disks in here, and their widths are like this, okay? Now let's just say that you have infinitely narrow disks, and you have, well, you have infinitely narrow disks, okay? So you have infinitely many disks, and each one of them has an infinitely small width, okay? So you're gonna have a disk in here, and another one in here, and another, and another, and another, and another, and another, and you keep growing. So that's what you're doing, okay? In the end, what you're gonna have is something like this. Something like that, okay? I'm gonna put this side by side here. So you see this beige, I don't know if it's beige or yellow disk in here, is just an approximation. See, representative disk of the infinitely narrow infinite disks that you have in here forming this solid. So you get the area of one disk plus the area of the next disk plus the area of the next disk. So what is going to be the area? Well, it's pi r squared, okay, because it's the area of a circle. A disk is a circle filled inside, okay? Because a circle, guys, is like this. Let me just put some, yeah, like that. This is a circle, but if it's filled, okay, you're going to fill it up in here, it becomes a disk. So it has this area, and then you're going to sum up all the areas until you have the volume. So an area plus another area plus another area plus another area. Okay? That's why it's integration. Integration is about infinite sums, remember? Okay. So let's see here. Okay, so let's talk about this solid right here. See that? Okay, So you have a function that square root of sine of x, which goes from x equal to 0, which goes from x equal to 0 all the way to x equal to pi. All right, and then you have these discs in here. This is a disc. Yeah, but it doesn't look like a disc, it looks like a stripe, right? Well, it's a disc. You see, the width's just exaggerated for you to see, because if the width is infinitely small, you can't even see it, right? And then you're going to revolve this disc around the x-axis, and you're going to form this solid, this three-dimensional here shape, okay? Looks like a balloon. Anyway, how do you do that? Well, you're going to get this disc plus this disc plus this disc plus this disc, right? Now, what is the disk? It's pi r squared. What is going to be r at any point x in here? It's going to be f of x. It's the distance from here to the x-axis all the way to the point of the function vertically above. Okay, so it'll be like this. At this point here, this is going to be r. So this thing is going to make a disk. Okay, this is the radius pi r squared. So you find the area of this disk plus the area of this disk in here, plus the area of the disk between them, right? Plus the area of the disk between them. You see that it's just getting closer and closer and closer, and it's forming a volume here. It just keeps going like this, okay? So that's what we're going to do. So the function is square root of x, and x goes from 0 to pi. Let's do this here. So it'll be the integral, the volume, right? The volume is going to be from x equal to 0 to x equal to pi of what? Pi r squared, because it's the volume of it's the area of the disk. So it's going to be pi, and what is r squared? Well, r is just going to be f of x, which is the square root of sine of x. Okay? So this square is just going to be sine of x. Dx, and that's it. Now, what is the integral of this? Well, it's going to be minus cosine of x, so it's pi, okay, times minus cosine of x. I can put like, yeah, okay, pi times minus cosine of x, and then you're integrating this stuff from 0 to pi. All right, so we're going to do pi times, what is cosine of pi? It's minus 1. With this minus becomes a 1, okay? And then you have to do minus. What is the cosine of 0? It's 1. With this minus, you're going to have a minus 1. So a minus 1 with this minus becomes a plus 1. There you go, 1 plus 1, 2 times pi, 2 pi. So what is 2 pi? 2 pi is the volume of this thing here. Okay, the volume of this solid, the space inside, the volume of the balloon. You can say that you have 2 pi cubic centimeters of air, 2 pi liters of air in there. Okay, 2 pi cubic feet of air, whatever. So that's it. It's the main idea. All right. Now, now we're going to have another one here, another example. Let me just erase this stuff. Okay. So here's the example. I'm going to make this big. All right. So you see the x-axis is down here. When it's revolving around the x-axis, then you have to, all you got to do is to say pi r squared, right? All you have to do is like, okay. You can see here that you have an f of x, which is the black thing in here. It's this black curve. And then you have the g of x, which is just a horizontal line, okay, right here at y equals 1. Okay, so it's revolving around the y equals 1, okay? This thing is going to revolve over here around this. It's not going to revolve, this thing right here is not going to revolve around the x-axis that's in here. So what do? Well, you find the solid from here all the way to the y-axis, right? You find the solid, and then you subtract from this solid, from this thing here, revolving around the y-axis all the way up here. So what is this going to be? Well, it's going to be the integral. It'll be the integral from minus 1 to 1, because you see it's minus 1, the value of x, all the way to 1, okay, of f of x, right, dx, pi f squared of x, right, because it's the radius squared, minus the integral from minus 1 to 1 of pi g squared of x dx. But because the limit of integration is the same, the limits minus 1 to 1 here and minus 1 to 1 here, okay, you can actually join these two together. So, yeah, just one thing that I'm thinking here. And then you go like, okay, but what do I do? Okay, well, what you can do, you're not going to just join these together like pi minus 1 to 1 of f squared of x, right, minus g squared of x dx. No, it's not like it was before. Actually, what you got to do here, well, you have to unite them, okay? But what you have to do is to translate, let me get the dark color again, otherwise you're not going to be able to see. You got to translate, because this thing is revolving, and I just want this distance revolving around this x in here, okay, not revolving around this x in here. There's going to be an axis here, which is this horizontal line, and I want to revolve around it. I don't want to revolve around here. So how do I do this? Well, all you got to do is translate this stuff down here. And how do I do that? Well, you see, what is this height? It's 1, right? So all I got to do is to do 2 minus x squared minus 1. If I get because you see, guys, 2 minus x squared for x is equal to 0. For example, this x. What is going to be 2 minus x squared? It's going to be 2. Well, the 2 is down here. But I don't want this whole distance revolving like this. No, I want this thing over here so that I can revolve it like this, okay, around the x-axis down here. So all I got to do is to take away this distance, and this distance is 1. So we do 2 minus x squared minus 1. That is the, hold on, before I join this stuff, what's going to be the real radius? The real radius, okay, the radius of x is going to be equal to 2 minus x squared minus 1, which equals 1 minus x squared. That is the real radius. That's the function, right? And now we can do this. Integral from minus 1 to 1 of pi, and this thing is squared, right? I'm already going to square it here, okay, so let me just bring it even more down. It's going to be 1 minus x squared squared, right? So it's going to be 1 minus 2x squared plus x to the 4th. It's this thing squared, okay? So let's copy down here. 1 minus 2x squared plus x to the 4th, okay, dx. This is going to be equal to pi times, right, from minus 1 to 1 of what? X. Now we're going to integrate it. And then you have minus 2x cubed divided by 3 plus x to the 5th divided by 5. We do that, all right? Okay. And now all we gotta do is to put that thing in there. I'm gonna put a pi here, which is this pi. Right, now let's go. First, do the 1. So it's gonna be 1 minus 1 cubed 1 times minus 2 divided by 3 minus 2/3. So minus 2/3. A plus 1 to the 5th. And then you gotta go like a minus, and I'm gonna open up another parenthesis because I'm gonna plug in this minus 1. So it's gonna be a minus 1 here. Minus 1 cubed minus 1 times a minus 2. So it's gonna be 2/3, okay? And here it's gonna be minus 1/5. Close the first parenthesis, close the second parenthesis. Now we do pi, and then I'm gonna do times 1 minus 2/3 plus 1/5 plus 1, right? Minus 2/3 plus 1/5. Yeah, so it's gonna be plus 1 minus 2/3 plus 1/5. Yes, and you do that in here. Well, you see, the minimum common denominator is gonna be 15. So this whole thing is going to be equal to pi, and I'm going to make something huge here. Okay, so it's going to be 15 minus 5 times 10 plus 3 plus 15 minus 10. And here is going to be a 3 plus 3. All right. So this is going to be a 5, right? Plus 3, 8, plus 15, 23, minus 10, 13, plus 3, 16. So this is going to be pi times 16 divided by 15. And that'll be it. Now, what the heck is this? Pi times 16 divided by 15. Well, it's not going to be this whole thing here revolving around x. It's going to be this shape translated down here, because I'm taking away this entire space here. What a mess. Okay, I'm taking away this entire space and I'm translating this thing, this area down here. Okay, so for example, this is going to be down here. This thing here in the middle is going to be down here. This top one here, this thing is going to be down here. Okay, so I'm taking one unit out of everything and I'm revolving it around x. A nice exercise. Okay, let me erase this. All right, let's see another one. Right, this thing of revolving surface of revolution, right? It's called the disk method. Okay, and now there's something else that's called the washer method. The washer method is when you want to get the disk, but you want the volume to have some kind of hole in the middle. All right, what am I talking about? I'm talking about this. It's like that. You're not going to count, you're still going to add up all the disks, okay? This disc plus this disc plus this one plus this one, coming from here all the way over here. It's bad because it's at an angle, but it's coming this way, it's coming inclined, okay? It has some kind of angle. It's not going to the left, it's not going forward or up. It's coming to the right and forward in my direction. Okay, so it's coming this way towards my face and to the right. It has some kind of angle here. Well, anyway, it's not going to be the entire disk. It'll be the entire disk minus the disk in here. Okay, so what is the radius going to be? Here's the thing. Let's do that. Okay, so we have the big R and the little r. So we have the integral, right, from a to b of the big disk. It'll be pi, the integral of r squared of x, okay, dx, minus pi, integral from a to b of little r squared of x dx. All right? That's the stuff. Now, this is one thing that you can do that you couldn't before. Remember when I said that you had, well, the example that we just did, I'm going to copy this thing here. I'm going to paste it here like that. Okay. Remember that you couldn't do like f squared of x minus g of x because you wanted the entire area and this area was being translated down here. You actually had to do 2 minus x squared minus 1. That'll be the new radius, and then you square that radius and you find it. Well, in the washer method, you can actually do this thing, f squared of x minus g squared of x, because you want that whole, all right? So in here, you can just unite these two, and you can do that. You can, to find the volume of this surface in here, this entire surface revolving around here, this disk, but with a hole inside, you can do this stuff in here. You can unite these two. It's going to be pi, the integral from a to b of r squared of x minus little r squared of x dx. Okay, then you can do that. So let's see an example. I'm going to show you the graph first, and then see here, this thing is going to revolve. Okay, when it revolves, this blue area is going to form the solid, and anything between the x-axis and the lower function in here, which is y is equal to x squared, this line is going to be a hole. All right, so let me show you what it looks like when it's done. This is what it looks like. See, there's a hole in here. It kind of looks like a jet turbine, jet engine for a plane. Okay, I mean, just it's supposed to be a dome, right? A solid, and then it goes inside like this, like a jet engine. I don't know. It kind of looks like it, not perfectly, but it kind of looks like it. Okay, so this dotted line in here is actually going to be the y equals x squared. That is this line. That is this dotted line. Everything in here is everything in this blue area. Okay, everything. So the dotted line here is this thing here. Everything in this that's forming the solid is going to be everything in this blue area, okay? And all this stuff in here is actually a hole. So you have this hole going inside like this. See that? Okay, so let's do it. I'm going to erase this thing here, like maybe even more like that. So it's going to be the top one minus the bottom one, all right? We have pi of the integral of x going from 0 to 1, x going from 0 to 1 of this top one here is going to be y is equal to the square root of x. So squared is going to be x, okay, minus the little r, which is going to be y equals x squared. But here's the thing, y equals x squared, when you square that, it's x to the fourth. So it's like that. And then you have a dx. Well, let's do it. Pi, let's integrate this stuff. From 0 to 1, it'll be x squared divided by 2 minus x to the fifth divided by 5. Okay? And then this is going to be equal to pi, And let's plug it in. It'll be 1 divided by 2 minus 1 divided by 5. Okay, and then you would have to do a minus in here and open another parenthesis, but you have x squared divided by whatever minus x to the 5th divided by whatever, and you're going to plug in zeros here. It's just going to be a 0, so don't worry about it. Okay, it's over. And this is going to be pi times the minimum common denominator is 10, so it's going to be 5 minus 2, which equals 3/10 of pi. Right? Now, what is 3/10 of pi? 3/10 of pi is the volume in this. So, is it the entire volume? I mean, what about even this stuff in here? This stuff in here? No. This is a hole. Okay, it's going inside. So it's just this little area here revolving around the x-axis. Okay. Isn't that an interesting one? See here? Okay. That. So we're going to revolve around the y-axis now. Okay. So you have this area here. You have this area that's going to revolve. Okay, which is fixed. I could use integrals too. The book actually uses integrals to find this area rotation here, the disk. Okay. But I don't have to because this thing is fixed, okay? It's coming from here to this point, all the way up to this point. It's just going to be 1. It's the same distance, okay? So we don't have to do that. I mean, it's pi r squared. What is r? It's 1. It's the distance from x equal to 1 all the way to x equals 0 because it's revolving in here, right? Around the y-axis. Okay. And then you add with this one, which is going to be also the distance here, 1, minus this whole, and this whole here, the little r is square root of y minus 1. Okay, so let's do that. So what is the volume that's going to be created by the bottom part? Is pi r squared. What is r? R is always going to be 1. So you have pi plus, and now I'm worrying about this part here, from y equal to 1 all the way to 2. The integral from 1 to 2 of what? 1, it'll be r squared of y, right? Minus little r squared of y. Now, what is the big r squared of y? Is 1. 1 squared is just 1. Minus the little r squared of y, which is, the book's already saying here that's the square root of y minus 1. Squared is just y minus 1. So, minus y minus minus 1 is going to be plus 1. Okay? Because you're squaring this and you have this minus, so it'll be minus y plus 1. dy, okay? Which equals pi plus the integral from 1 to 2 of minus y plus 2 dy. So it'll be pi, this equals pi plus, you have minus y squared divided by 2 plus 2y from 1 to 2. This equals pi plus, well, let's do it. I'm gonna put this in parentheses. Yeah, I'll put it in parentheses. So 2 squared, 4 divided by 2, 2. With a minus, you're gonna get a minus 2 here, right? And then you have a plus, and 2 times 2 is equal to 4. And now you have minus, and I'm going to open up another parenthesis. We're going to plug in the 1. So you have 1 squared divided by 2, 1/2 with a minus, minus half. And then you have a plus and 2. Close, close. All right. So this thing is going to be equal to pi, okay, plus 4 minus 2 is just going to be 2, okay, minus, I'm going to open up the second parenthesis, 2 minus half is going to be 1/2, which is 3 divided by 2. So 3 divided by 2, close, close. This equals to pi plus 2 minus 3.5 is going to be half, okay? So it's just going to be half, like this. Because it's 2 minus 1.5 is just going to be half. So there you go, that's it. Let's see here. Yeah, there's something that I forgot in here, right? There's something that I forgot in here. It's my mistake, guys. I put the pi over here, right? But when I was doing this integral, I forgot that you also need another pi in here because it's the formula is pi, the integral of r squared of y in this case, minus little r squared of y, okay, dy. So yeah, I forgot. So you got a pi in here. You have a pi here, you have a pi here, you have a pi here, okay? That means that you also have a pi here. This means that you're going to have a pi here, multiplying. So it's 1 pi plus half pi. It'll be 1.5, this 3 pi divided by 2, yeah. Because this first pi here confused me. I thought that I had already put the pi in the second integral, but I didn't. Now we got another thing here, okay, which is this thing here. This when revolving, okay. Now here's the thing, okay. I'm not going to revolve this line around this because if I had to do like, what is the big R, okay, the whole distance here, square root of 25 minus x squared. I was going to have to do square root of 25 minus x squared minus 3 to translate this thing down and then revolve just this blue area around the y-axis. Around the x-axis, but that's not what I want to do. I want to revolve everything and then take this little r here out, okay? So I'm going to get this, it's the washer method, so I'm going to get this function, revolve it around here, okay? And then minus this function here, revolving around here too. So that's what we're going to do. It'll be pi times the integral, we're integrating blah 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 from x equals minus 4 to x equals 4 of r squared of x. It's going to be 25 minus x squared minus y minus the little r squared of x. It's the big R squared of x minus the little r squared of x, right? Which is, well, the y is just 3, so it's going to be 9 minus 9. We'll put a minus 9 in here, dx. And this whole thing, 25 minus 9 is going to be 16. Let's just put the 16 in here. Okay, so it'll be pi times 16x minus x cubed divided by 3. Oh yeah, this is supposed to be a brackets, not parentheses. And going from minus 4 to 4, this equals pi. And well, let's just plug in, right? I'm going to make big here. So 16 times 4 is going to be 64 minus this thing is going to be 64 divided by 3. Okay, and then you have a minus. I'm going to try to do this faster this time. This is going to be minus 64 with a minus plus 64. This thing is going to be minus 64 over 3, okay, because it's minus 4 cubed, minus 64 over 3, with this minus becomes a plus. But because we're doing this, it's another minus. So it'll be another minus 64 over 3. So the whole thing is going to be 128. Minus 128 over 3. Okay, so it's going to be pi, and then you do 3, okay. Now, 3 times that, going to be 12 goes 1, 18 and 1, 19, all right. Minus 128 plus another 192 here, okay. So this is going to be pi times, I'm going to put this 3 here, and it'll be 192 times 2, it's going to be 4, 18 goes 1, 2, and 1, 3, okay, minus 128, 14 minus 8 is 6, 7 minus 2 is 5, 256 over 3. 7, 13, yeah, that's it. That's it. And just so you guys see what's happening, as you revolve this thing here, okay, as you revolve this blue area with this hole inside, this solid is going to be formed. There. See the hole in here? Guys, I think that's it for this video. See you guys in the next one.